G'day. I've had some questions, some emails about curved mirror ray diagrams, and seeing as I'm homesick, I thought I'd just make a video going through this again. Hopefully this will help. So ray diagrams are all based on two rays. There's three you can draw, but you only need two of them. So the two rays that you need to really worry about. The first one is a ray that's parallel to the principal axis will always reflect through the focus or away from the focus, depending on the mirror. Like if the focus is behind the mirror, then the ray can't go through the focus, but it will go away from the focus. I'll go through some examples where that's the case. The second one is the opposite of that, a ray that is through or towards the focus, if the focus is behind the mirror. It will always reflect parallel to the principal axis. So those two are just kind of the opposite of each other. There is a third one you can draw, which is a ray that is incident at the pole where the principal axis meets the mirror. It reflects it back at the same angle as if it was a plane mirror. But that one's not terribly useful. I'm just mentioning it now because it becomes useful, very useful later when you do lenses, but we're not really going to use that one much. So we're just going to worry about these two. And I'll use these color codes. So I'll draw them in red and green so you know which one's which. So go through several cases. I think there's four different cases I'm going to go through, different types of mirrors and where the object is and what the ray diagrams look like. So start with a concave mirror when the object is quite a long way away, beyond double. It's like beyond two times the focal length. Um, so beyond the center of curvature of the mirror. So in this case, so we've got those two rays we can draw. So the first one is a ray that goes parallel to the principal axis, reflects through the focus point. Okay? And the second ray, remember there's rays going from the object in all directions, but we're just looking at two of them. A ray that goes through the focus point reflects parallel to the principal axis. Okay. Now, the third one, if we wanted to draw it, would be this one. Okay. A ray that's incident at the pole reflects at the same angle to the principal axis, but we're not going to use that one, so I'm just going to ignore it. But you notice that it did cross at the same point. Okay. So we just need those two. Okay. So the image will be formed where the reflected rays crossed. Okay. So the rays that are moving away from the mirror, where did they cross? That's where the image is formed. Okay. So in this case, the image is smaller than the object, it's upside down, and it's real. You can tell it's real because there are actually real light rays crossing at that point. You can also, rule of thumb, a way of knowing that it's real in level 2 NCEA is if it's upside down, it's real. And if it's the right way up, it's virtual. But that's just like a rule of thumb. It's not always true, but for the cases that you need to worry about, it will be. All right, so that's first one. A concave mirror with the object is beyond 2f. So now we'll do the same thing, but when we move the object a bit closer. So now the object is between f and 2f. So we've just moved the same object a bit closer, and we'll do the same ray diagram. So we've got the same first ray. So a ray that's parallel to the principal axis goes through the focus point, and a ray that is through the focus point reflects parallel. Now in this case, the image will be formed where those reflected rays cross. Okay. In this case, it's still upside down, okay, which means it's going to be real because there's real light rays crossing there. But this case, it's actually larger, okay. There is a case which I haven't done here actually, which is when the object is at 2f, the object and the image will be the same size, but be inverted. So if the object is really far away, the image is smaller, and if the object is closer to the focal point, then the image is bigger, but they're both upside down and real. Now, what if the object goes beyond the focal point, like goes inside the focal point? When the image is at the focal point, interesting things happen. I'm not going to go through that now, but maybe you can have a look at that one yourself. So, when the object is between the mirror and F, now we draw the same rays, okay? So we start a ray that goes parallel, goes through the focus point, okay? Now, the next one is a bit tricky because if you drew a ray that went from there through the focus point, it would actually be going away from the mirror, okay, which will never reflect off the mirror. So what we need to do is actually draw one going the other way. Imagine a ray that had come from the focus point and went past the top of the object like this, okay? So it's gone through the, like a ray that had gone through the focus point just past the top of the object will reflect parallel to the principal axis. Okay, so that one's a little bit tricky. Now, where is the image formed? The image is formed where the reflected rays cross. Now, those two reflected rays will never actually meet. They are moving away from each other. They're diverging, which means they never really cross. But it looks like they have crossed. If you extend it back, if you extend them back, they look like they would have crossed back behind the mirror, which means that's where the image is formed. Okay. Now, in this case, the image is larger, it's upright, so it's the same way up as the object, and it's virtual. The light rays do not actually cross there, okay? So there's no real image there, okay? But that's where it looks like the image is. But because it's virtual, you could not project that on a screen. All right, so those are the three concave mirror cases. Just have a look at a convex mirror. Convex mirror is a little bit simpler in that there's only one case really. It doesn't really matter where you put an object in front of a convex mirror. You're going to have the same case. Concave mirror, there's like several different things that can happen. But convex mirror, there's only one, okay? But we use the same rules. So a ray that goes parallel to the principal axis. Now, it can't go through the focus point because the focus point is behind the mirror, but it can reflect away from the focus point, okay? As if it had come from the focus point, okay? The second ray, a ray through the focus point. Now again, it can't get to the focus point because that's behind the mirror, but it's traveling as if it was going towards the focus point, will reflect parallel to the principal axis, okay? Now again, those two reflected rays never meet. They're diverging, they're traveling away from each other. But it looks like they would have crossed back behind the mirror. So that's where the image is formed. Okay, so the image is formed where the reflected rays would have crossed. So in this case, it's smaller, upright, and virtual. There's no real light rays are crossing in that image location. And that's always the case for a convex mirror. No matter where you put the object in front of the mirror, you're always going to have a smaller, upright, virtual image. The ray diagram will always look like that. It's just that sort of second ray, the green ray might change a bit depending how close. So the image could get a little bit bigger or smaller, but it will always be smaller than the object and upright and virtual. All right, so those are the four main cases of ray diagrams that you might need to draw. I'll save a PDF of that and I'll put it up in the Google Drive that we used during lockdown. I hope that helped.